going to finish up with some applications to business. So drawing from things we learned previously about supply and demand and expanding it a little bit now that we have calculus. So something we talked about before in our class previously and in the previous business math class is the idea of equilibrium. So if we have supply and demand where the two match up is our equilibrium point. So if we had a graph of supply and demand, something like this, supply is typically increasing. So the quantity tends to increase as price increases. And then demand tends to decrease. So as the price increases, the quantity demanded tends to decrease. And then where they cross each other is the equilibrium point. So where supply and demand are the same. So for a quick example here, let's say we have the demand curve of 50 minus 1/4 x and the supply curve x minus 25. If we wanted to find the demand curve, what we would do is, the equilibrium point, we would set these equal to each other. So 50 minus 1/4 x equals x minus 25. And then we would start solving. I'll add 1/4 x to both sides. Add 25 to both sides. Multiply both sides by 4/5. So x is going to be 60. So let's see with how these are set up. We have Q and X, so that would be our price. And then to find Q, we would just plug it into one of the equations. So maybe the 60 minus 25 is nice and fast. So quantity of 45 at a price of $60 would be equilibrium for this coffee maker. So we've done that previously, but now let's expand to how we can use this equilibrium point to tell us more. And that's going to come through consumer and producer surplus. So most likely, if you're listening to this, you are a consumer. You purchase things, you buy things because you need them or you want them. And with that, we could talk about this idea of consumer surplus, which comes to this idea of utility, but it's this idea of the benefit that we receive beyond the price that we paid for the item. So there's a certain value to the item, but there's a utility or this kind of amount of pleasure that we get from the item that goes beyond that price. So that's what consumer price is. So when we use consumer surplus, what we're going to use is we're going to use the equilibrium point, and the notation we're going to use here is capital Q, comma, capital P for the quantity and price. So consumerism is based on the demand part of our supply and demand. When we talk about producer surplus, that'll use supply. But if we want consumer surplus, we use the demand function. So to calculate the consumer surplus, we're going to take the definite integral from 0 to q, where q is the x-coordinate of our equilibrium point, of our demand function, d of x dx, minus q times p, where q is that x-coordinate, p is that y-coordinate of our equilibrium point. So we're using our equilibrium point and demand function to calculate consumer surplus. Producer surplus can be a bit harder to kind of visualize because not often are we in the position of producer at this point of our life, of producing a product, supplying a product, things like that. But the idea of producer surplus is the benefit to the producer beyond the price. So whatever they're supplying, there can be this added benefit beyond what they're supplying in terms of price. So producer surplus is that kind of thing of, again, this price that goes beyond just the price that's set. So I know that's a bit confusing. It's just consumer surplus, I think, is more relatable as a consumer, but producer is a little trickier. So producer surplus, we're going to take Q times P. So again, the two values from our equilibrium point minus the definite integral from 0 to Q of our supply function, S of x dx. So that will be our calculation for producer surplus. And the question will tell us which one we're looking for. Then there's also this thing called total gains that I wanted to add in here. So total gains is where you add together the consumer surplus and the producer surplus. Consumer surplus plus producer surplus. Okay, if we add those two surpluses together, that's what we would call total gains. Okay, let's look through some examples here. So we have a demand function, x minus 4 quantity squared. So is the price that consumers are willing to pay for x units of an item. So x is the number of units. So it's the quantity. And then s of x, so our supply function, x squared plus 2x plus 6, is the price that producers are willing to accept for x units. So producer is what they're supplying. So find the equilibrium point. So what we're going to do is take those two functions and set them equal to each other. So x minus 4 quantity squared equals x squared plus 2x plus 6. I am going to FOIL out the x minus 4 squared, so that'll be an x squared minus 8x plus 16 equals x squared plus 2x plus 6. Subtract x squared from both sides. Add 8x to both sides. We'll have 16 equals 10x plus 6. Subtract 6 from both sides. And we're getting x equals 1 out. So that will be our quantity. And then for price, we just need to plug 1 into one of the equations. So like 1 minus 4 quantity squared, negative 3 squared, so 9. So for equilibrium, we have a quantity of 1 item at a price of $9. So let's find the consumer surplus. So for the consumer surplus, we want to use the demand function. So we're going to take the definite integral from 0 to q, which we just found q is 1. And we're going to use our demand function, so the x minus 4 squared. We could leave it in that form. I'm gonna go ahead and use the FOILed out form. So x squared minus 8x plus 16. It would be fine either way, but this is a little easier. We can just use the power rule for taking the antiderivative. And then we're going to go, so we have our definite integral and then minus q times p, so 1 times 9. Okay, so with that, we're going to have x cubed over 3 minus 8x squared over 2, so 4x squared plus 16x. And we're evaluating that from 0 to 1, and then on the outside we have a minus 9. So plugging in 1, we'll have a third minus 4 plus 16. And if we plug 0 in, all of that's going to wipe out. So then we just have a minus 9 at the end there. And if we just throw that into a calculator, it should be a 10 thirds or a $3.33. So the benefit that the consumer gets beyond this price of $9 is $3.33. All right. Producer surplus. We're going to take q times p, so 1 times 9. And then we're going to go minus the definite integral from 0 to q, so 0 to 1. And this time, because this is the producer surplus, we want to use the supply function. So x squared plus 2x plus 6 dx. So we're going to have 9 minus, and then we'll have x cubed over 3 plus 2x squared over 2, so x squared, plus 6x, and evaluating that from 0 to 1. So 9 minus, if we plug in 1, we'll have a third plus 1 plus 6. If we plug in 0, that all wipes out. And a calculator will tell us that's $1.67. So that's the added benefit that the producers are getting with this supply that they're offering there. What was I going to say? Oh, total gains. If we were asked to find the total gains, we would just take the $3.33 plus the $1.67. So with this, there is a total gains of $5. Okay, one more example here with consumer and producer surplus. So suppose we have the demand function negative 0.8Q plus 150, and supply is 5.2Q. And we're using Q for quantity, P for price. Okay, finding the equilibrium point. So we're going to take negative 0.8Q plus 150 and set that equal to 5.2Q. Add 0.8Q to both sides. So we have 6Q equals 150, divide by 6. So we get Q equals 25. And then, so Q is 25 for equilibrium. And then for the price, we just need to plug in 25 into one of the functions. How about 5.2 times 25, which is 130. So we have our equilibrium at a quantity of 25 units at a price of $130. Let's find the consumer surplus. So we're going to go the definite integral from 0 to Q, which in this case is 25. We're going to use our demand function, so negative 0.8Q plus 150. We're going to go dQ minus Q times P, so 25 times 130, which is 3,250. Okay. Let's take the antiderivative, so negative 0.8, that would be Q squared over 2, so negative 0.4Q squared, plus 150Q, evaluating from 0 to 25, minus 3,250. And if we plug in 25, let's see, negative 0.4 times 25 squared, plus 150 times 25, that's a 3,500. If we plug in 0, it's all going to wipe out, so we're not really getting anything from that. So we're having 3,500 and then subtracting the 3,250 at the end there, which is 250. So there's a consumer surplus of $250. For producer surplus, we're going to take Q times P first, so that 3,250, minus the definite integral from 0 to 25. And then this time we're going to use our supply function, so 5.2Q dQ. So 3,250 minus, and then the antiderivative of 5.2Q, let's see, Q squared over 2, so that'll be a 2.6Q squared from 0 to 25. If we plug in 0, that won't do anything, so we're really just interested in plugging 25 in. So 2.6 times 25 squared is 1,625. So 3,250 minus 1,625, which is $1,625, is the producer surplus. And then they didn't ask for it here, but I just want to keep adding it in, that if they wanted the total gains, then we would just add those together. So 250 plus 1,625. So there would be a total gains of $1,875. Okay, so that's consumer surplus and producer surplus. So using the equilibrium point, talking about what kind of benefit are consumers getting and producers getting beyond the price that is paid and supplied for with that quantity.